To summarize this, the joint equation of a pair of straight lines passing through the origin is given by ax square plus 2hxy plus by square is equal to 0. Now, if an equation of this type is given to us, how do I find out the individual equations of the straight lines? Well, you can let the two lines be y is equal to m1x and y is equal to m2x, such that m1 plus m2 equals minus 2h upon b, and m1 times m2 is a upon b. Solving these two equations, you can get the values of m1 and m2, and thus you can write down the individual equations of the straight lines passing through the origin, whose joint equation is ax square plus 2hxy plus by square is equal to 0. Now let's look at examples which illustrate this method. If the equation 2x square plus lambda xy plus 2y square equals 0 represents a pair of real and distinct lines, then what's the value of lambda? We have seen here that when h square is greater than AB, it represents a pair of straight lines which are real and distinct. If h square equals AB, then it represents one single line passing through the origin. And if h square is less than AB, imaginary lines. And so since we require the two lines to be real and distinct, therefore 2x square plus 2 times lambda by 2 xy plus 2y square equals 0, so that we get a in this as equal to 2, h as equal to lambda by 2, and b as equal to 2 again. So for real and distinct lines, h square greater than ab, and so lambda by 2 the whole square is greater than 2 times 2. Lambda square by 4 is greater than 4. So we get lambda square greater than 16, which gives us lambda greater than 4 or lambda less than minus 4. And thus we get option C, which should be the correct interval for lambda here. So option C is the correct answer. Let's do one more question on this method. If the sum of the slopes of the lines given by x square plus 2cxy minus y square equals 0 is 4 times their product, then C has the value. Which of these values? That is minus 2, minus 1, 2, or 1. So again, ax square plus 2 times hxy plus by square equals 0. So when you have the slopes of the lines as m1 and m2, m1 plus m2 is minus 2h by b, and m1 m2 is a by b. Our equation here is x square plus 2c xy minus y square equals 0. So here m1 plus m2 equals minus 2c divided by minus 1, so that's 2c. The product of the slopes m1, m2 is a upon b, so that's 1 divided by minus 1, so that's equal to minus 1. What is given? The sum of the slopes m1 plus m2 is 4 times their product, 4 times m1, m2. Substituting the values, we get 2c equals 4 times minus 1. And so we get c equals minus 4 divided by 2, so that's minus 2. And thus we get option A as the correct value of C for this question.